In this example, we're going to try to solve for x in the following equation. 5 to the power of x minus 2 times 25 to the power of 3 minus x is equivalent to 0.2. What we'd like to do first on the left-hand side is try to simplify this a little bit so that we have only one base. Notice that 25 can be written as 5 squared, and this is going to allow us to do some simplification with our powers. So now we can rewrite this as 5 to the x minus 2 times 5 to the 2 times 3 minus 2 times x. And again, we're going to keep on simplifying the left-hand side. We have like bases that are multiplied together, so we can go ahead and add our exponents. This is going to give us 5 to the x minus 2 plus 6 minus 2x. And going ahead and simplifying, we're going to get negative 2 plus 6, that is 4. And x minus 2x is going to give us negative x. Now, in order to solve this equation and isolate the power of our exponent, we can use the inverse properties of exponential and logarithmic functions. That is, if I apply log with base 5 to both sides of this equation, the action of the logarithm of base 5 followed by the exponential with base 5 are going to undo each other, and we're going to be left with 4 minus x on the left-hand side. So this leaves us with 4 minus x is equivalent to log base 5 of 0.2. Let's go ahead and try to simplify the right-hand side a little bit. We notice that 0.2 is really 1 over 5. Or 0.2 is 5 to the power of negative 1. So I'm going to rewrite this as log base 5 of 5 to the negative 1. And again, notice that we have log with base 5 followed by an exponential with base 5. Those actions are going to undo each other, and on the right-hand side we're going to be left with negative 1. So now we have a linear equation in x. I am going to add x to both sides. That gives us 4 is equal to negative 1 plus x. And then I am going to add 1 to both sides, and that's going to give us 5 is equal to x. And since our exponential functions are defined for all values of x is equal to 5 is going to be the only solution to our original equation. Next, let's see if we can use the techniques of this section to try to determine the inverse of the following function, e to the x minus 3. Well, if we follow the steps that we had from a few lessons ago, we're going to replace f of x with y, and write this as y is equal to e to the x minus 3. And then let's next interchange x and y, so we have x is equal to e to the y minus 3. Now from here, our goal is to try to solve for y, and if we can do that, we end up with the inverse function of f. But how is it that we can solve for y in this equation? Well, in order to get that power, we can apply the natural logarithm to both sides of our equation. That is, we can say that the natural logarithm of x is equivalent to the natural logarithm of e to the y minus 3. And now, since we have the natural logarithm of the natural exponential, those two functions are inverses and are going to undo each other, and on the right-hand side we're going to be left with the power, or just y minus 3. And we have one final step here. We can get y by itself by adding 3 to both sides, so we get the natural logarithm of x plus 3 is equal to y. So our inverse function in this case we can write as f inverse of x, and it is the natural logarithmic function plus 3.